Hi everyone, welcome to the online flip learning webcast and today topics is on the stress and strain in materials. So first we understand about the fundamental principles about the equilibrium and the stability. If you see if there is a body and the number of forces are acting upon that body. So it is very essential for a material to very machine to be working that it should be the stabilized and number it should be in the equilibrium position. Means if there is a structure of the material and number of forces are acting on a body, then summation of all the forces acting on a body should equal to zero. So there should be the all the forces must balance it to zero for the stability, and it should be in the static equilibrium. Means every there is a structure upon which the machine is moving and on which is machine is working, then it should be in the static equilibrium. There should not be the unbalanced forces on that. If there is a unbalanced forces that act upon a body, if number of forces are acting upon a body, and if the summation of all forces is greater than zero, then it will lead to the unbalanced forces leads to collapse of the that material. So that material is not accepted in the engineering applications, in the mechanical engineering or the electrical engineering applications. So that's need to be considered. So the first is the basic thing we need to understand before going through the stress and strain in the materials is the load. The load is basically the force that is act upon the body. If there is a body and there is a forces are acting upon a body, that forces is also called the load. Okay, and in the loading, there are basically the two kinds of loading. One is a static loading and one is a dynamic loading. If you see there is a body and which is under the static positions and number of forces are acting upon a body and summation of all forces equal to zero. So this is called the static loading. But if the body which is in the movement state and the number of forces are acting upon a body, so some summation of all forces should be equal to zero. So that is under the dynamic loading. Okay. So in the loading, there are five different types of loading we implement in the mechanics of the materials. The first one is the compression. Suppose there is a body and the forces are acting or to each other. It will compress that material to this shape. So this is called the compression loading. If there is a body and the two forces are acting against to each other and they would shrink that body, and that shrinking that they will stretching that body, that stretching would call the tensile or tension loading. Third one is the bending loading. If the length of the material is so big, then the load is applied upon the body, it will cause the deflection in the body. So this deflection is due to the bending load. Okay. The fourth one is the torsion loading. If there is a body and which is rotating about its axis, so that rotation will cause the rotation will cause the stiffness in the material or failure in the material, and that it will experience a loading. That loading would be called to the torsion loading. Fifth one is the shear loading. If suppose there is a material and the forces are acting upon the edge of the body, and this due to the edge of the body, it will cause the rotation of that body. So this will cause the this is the shear loading. Okay, this is the five different types of loading that we considered in the mechanics of materials. Now we come onto the concept of the stresses. The stress is the internal force per unit area that develops within a material under a load. Suppose there is a body and the force are acting upon that body. So there will be internal force that is generated by this material against that forces. This is called the reaction forces. This is reaction forces. This is reaction forces. So that reaction forces is the basically the stress. So It is a fundamental to understand the concept of the forces. If there is action forces, then the opposite, the forces that is applied by the body, that is called the stress. So it is, and the unit of the stress are the pascals, and it is generated by the sigma, and it is pascals or the Newton by meter square. So it is generated by the sigma. It is the ratio of the force per unit area. Suppose there is a body and the forces are acting upon that body. So sigma, that is stress, is the ratio of the that forces that is acting upon a body per unit area of the body. This is the, and the units of forces are newtons, area, meter square. So the units, so the stress is equal to Newton per meter square or pascals. Okay, this is to be understand about the stresses. Now the basic types of stress. First one is the normal stress, and under the normal stress they are basically tensile and compressive stress. Suppose there is a body and the forces are acting upon a body. If the forces are acting at the 90-degree to the body, okay, so this is the normal stress, and it can be tensile and compressive stress. If there is a, if the forces are acting on the edge of the body, okay, on the edge of the body, so this forces will and the body will induce stress, and this stress is called the shear stress. And there is another stress which is called the combined stress or the principal stress. It is just an addition of the normal stress and the shear stress. Okay, this is the addition of normal stress, and shear stress is the combined stress, or we can also call it the principal stress. So in the types of stress, as is related to the loading, the types of stress are the the compression stress due to the compression loading, tensile stress due to tensile loading, bending stress due to bending loading, torsion stress due to torsion loading, and shear stress due to shear loading, because it is just basically the adhesive force that is developed by the body against the deformations. Tensile stress is the pulls material apart like stretching a rubber band. Okay, compressive stress pushes the material together like squeezing a spring. Okay, third one, shear stress, causing sliding between the material layers occur in the connections and the rivets. If for example, there's a body and the forces are acting on the edges, this is called the shear stresses. Now the torsion stress is due to in the rotational body due to the twisting, and first and the bending stress when the length of the body is so high and load is applied, so it will cause the deflection in the body. So that the deflection in the body due to loading, and this is called the bending load, and reactions to that load is the bending stress. Normal stresses are the torsion stress and the tension stress and the compression stress. If the forces are applied against in the opposite to each other, there will be stress induced over this side, and it will, if it is cross its breaking point, then there will be the failure at this point. Similar in the compression way, if the forces are applied to each other, and if the material stress is again is crosses its durability is maximum limit, then it will cause the breakage at this side. Okay, let's understand how to calculate the stress. We by understand a simple example. There is a diameter of 20 mm, tensile forces of 10,000 newtons. Calculate the stress in a road. What is the stress is equal to force per unit area. So we have a force is the 10,000 newtons. We need to calculate area. We have diameter we have diameter is equal to 20 mm. We need to get the area. It can be calculated as pi by 2 d square or pi r square. So we change into the diameter to the radius. Pi r is equal to d by 2. then pi r square, pi into 0.01 square, this is our area. Then force per unit area, force is 10,000, area is 3.142 into 10 raised to power minus 4. So we get the stress is equal to 31.8 megapascals. So this is a way to calculate the tensile stress. Now the shear stress, it is generated by the tau is equal to force per unit area. So if there is a rivet joint, so this is kind a rivet joint, and the forces are acting on the edges of the body. It is of the 5000 newtons. Okay, 5000 newtons is forces acting upon a body, and the diameter is the and with diameter is the 10 mm. So firstly we convert the mm into the meters, and after then we get the area is equal to pi by 4 d pi by 4 d square. So we calculate the area. Now tau is equal to force per unit area. We got force, we got area, so we got the stress is equal the shear stress is equal to 63.66 megapascals. Bending stress, it is again calculated is this the symbol is sigma, but is calculated by my upon I. M is the moment, y is the m is the moment, y is the distance from the neutral axis, and I is the moment of inertia. Moment of inertia is basically defines as the how resistive that material against the loading. Now the torsion stress. So torsion stress is basically apply is equal to the tau, and is formula is equal to the torque into the R divided by J. Okay, this is the of the torsion stress. Now we come into the strain. Strain is a very important concept in the mechanics of material and the machines. So the formula is the delta L by L. Is the delta L is equal to change in length by the original length. So it is a ratio of change in length divided by original length. So it is the axial strain that is due to the axial stress, shear strain that is due to the shear stress, volumetric strain that is due to the principal stresses. So let's understand with an example. That's just is a 2.5 meter long, stretches by 2 mm under the tension. So strain would be calculated as delta L. It was the 2 mm. We convert into the meters. It will be 0.002 meters divided by the length. It is 2.5. So the strain would be 0.0008. So this is our this is we calculate the strain in the materials. Now there is a very important concept in the mechanics of material and machine, that is the shear stress diagram. There will be stress on y-axis, there is a strain on the x-axis, and this is the behavior of the any ductile material. So this point is called the elastic limit point, and this is the point. And then if we keep on applying the forces on a body, then there will be continuous deformation in the material. If we increase on the stress in the material, and there will be a complete on strain in the material. At this point it is follow the linear way, and this point is called the elastic limit. And after then, if we keep on applying the load on that body, then this will leads to the ultimate strength point, and this is the maximum strength point that the material can bear, and this point where is under the plastic deformations. And if we keep on pressing that material, then this will leads to the fracture of the material, means it will be the breaking point. Okay, now this so it is the stress strain diagram is the first depend upon the elastic limit is the to the limit where the stress is directly proportional to strain. Means if we keep on applying the load on the body, there will be deformation in the body. But if we remove the load on a body, then it will regain its original shape. Okay, suppose if there is a body, we applied a force on it, it will be deformed. But When we remove the force, it will again regain its original shape. So this is called the elastic limit, the maximum stress with the full recovery. Then the yield strength. Yield strength, this is a point, is a that strength where the material's permanent deformation begins, because at this point the material will not regain its original shape. If once it get deformed, it not won't get its shape back. Third one is the ultimate strength, is the maximum stress that that the material can bear about, and after this point there will be the breakage in the materials. Okay, this is the our stress strain diagram. So as we see in the diagram again, this is the elastic limit, and after then if we keep on applying the load on the body, this will lead to the ultimate strength, and after the ultimate strength, this is the maximum point where the after which the material cannot bear the load, and after crossing the maximum point, this will lead to the fracture. The material will break. So here we apply a very important formula here, that is Hooke's law. Hooke's law signifies about the elastic limit of material. Okay, means up to the elastic limit, the stress is directly proportional to strain. Okay, the stress is directly proportional to strain up to the elastic limit. This is applies the Hooke's law. So if we move the proportional, then it becomes the stress is equal to Young modulus dot strain. So Young modulus can be equal to the ratio of stress upon the strain. Okay, this is for the normal stress, and for the shear stress is equal to tau was the shear stress is equal to G is equal to shear modulus dot is the shear strain. So shear modulus is the ratio of the shear stress divided by shear strain. Okay, this Hooke's law implements to the maximum elastic limits, and after the elastic limits, the plastic deformation starts, and after the ultimate strength, till the ultimate strength is the maximum load that the material can bear, and after the ultimate strength, the material comes into the breakage point. So this is our concept of the stress and strain in materials. Okay. So on the basis of these presentations, there is a quiz over there. Kindly scan this barcode and there will be a set of 10 questions. So go through the questions and access your knowledge about the stress and strain. So thank you very much for viewing this video. Bye bye.